Welcome back. There's a question on the board under Newton's laws of cooling. A thermometer is removed from a room where the temperature is 70 degrees Celsius and it is taken outside where the air is 10 degrees Celsius. After 0.5 minutes, the temperature reached 50 degrees Celsius. What is the reading of the thermometer after 1 minute? How long will it take the thermometer to reach 50 degrees Celsius? This is a question on Newton's law of cooling that I proved. So we have been given some parameters and we have to find some parameters in this. So this is a thermometer is removed from a room where the temperature is 70 degrees Celsius. It means our T is what? 70 degrees Celsius. So in temperature, under Newton's law of cooling, our temperature it is measured in degrees Celsius, while our time is measured in minutes. We don't need to convert to seconds, so it is measured in minutes. And it is taken outside where the air is what? 10 degrees Celsius. It means surrounding medium is what? The reason why we have our T must be greater than our surrounding medium is what? Our temperature of the body and temperature of the surrounding. Which one is the greatest? Temperature of the surrounding is greatest. Since if temperature of the body is greater than the temperature of the surrounding, it means what? We have minus K. So that's why we get our K as a constant when I was proving the other time. So our temperature of the surrounding, so outside this is the surrounding of the environment. What do we have? We have what? 10 degrees Celsius. That is our Tm is what? 10 degrees Celsius. Our Tm is 10 degrees Celsius. So according to our formula for Newton's law of cooling, temperature is equal to what? Temperature of the surrounding plus as constant of exponential minus raised to power kt. So our temperature is what? 70 degrees. Our Tm is what? 10 degrees Celsius plus what? C exponential minus kt. If you connect that times here, what are we going to get? Remember that at temperature, T is what? T is time. What do we have? Our T is what? Initial. Because we are not given time. What's this one? When the temperature is taken outside at 70 degrees Celsius and outside the air 10 degrees Celsius, temperature of the body, temperature of the cell, we are not given the time. So we make our T as what? Initial, which is 0. So we now have here, we are going to have 0 here. So we now have 70 is equal to 10 plus C exponential minus K times 0, we have 0. Exponential raised to power 0. So anything raised to power 0, we have 1. So we now have 70 is equal to what? 10 plus C times 1, we have what? This is like this. So now I have 70 minus 10 is equal to C. Our C is what? 60. So here we now have T is equal to what? Tm plus 60 exponential minus kt. So this is the equation connecting them. This is the equation connecting the temperature of the surrounding, because we are getting our constant as this. So whenever all this now will now be using it to substitute this. Remember that if the temperature of surrounding, we use it, we are being given as well 10 degrees Celsius. We are going to use temperature of surrounding 10 degrees Celsius to solve all the question under this, because since it must be taken it once, and the temperature of surrounding is at that moment, we only have a word, an environment at that moment. So it is not going to other environment. So it is just like at that moment it happened. After 0.5 minutes, so it means our time is what? 0.5 minutes. What do we have? The temperature reached 50 degrees Celsius. That is the temperature of the body. The temperature of the surrounding reached what? 50 degrees Celsius. So it means we have to substitute this into this. We have to substitute this into this. But this is our equation connecting it. So our T is what? 50 degrees Celsius. So we now have our temperature of the surrounding 10 degrees Celsius. That is 10 plus 60 exponential minus K. Our time is what? 0.5 minutes. If you multiply a constant minus K times 0.5, get what? Minus 0.5 K. So we now have 50 is equal to 10 plus 60 exponential minus 0.5 K. So from here, we can collect like terms. We can take 10 to here, we get 40. So we have 50 minus 10 is equal to 60 exponential minus 0.5 K. So we now have here 40 is equal to what? 60 exponential minus 0.5 K. So from here, we can divide both sides by 60. So that we now have what? Exponential minus 0.5k. So here we now have what? 40 all over 60 is equal to 60 exponential minus 0.5k all over what? 60. So this is able to cut. So 40 divided by 60, what are we going to get? 40 divided by 60, we are going to get 0.666666 is a rational number. You have to take it to what? First significant figure. You now have 0 is an irrational number. 0.6667 is equal to exponential minus 0.5k. So what are we going to do here? This is an exponential. We have to take this exponential out. What are we going to take? We have to take the natural log of both sides. If you take the natural log of both sides, natural log will cancel exponential, exponential will cancel natural log as well. So we now have ln 0.6667 is equal to exponential ln minus 0.5k. So this one will be able to cancel. So we now have what? Ln 0.6667 is equal to minus 0.5k. So from here, what is our ln? So we now put this calculator ln 0.6667. We have minus 0.4054. So minus 0.5k. We want to get our k. Our k will now be minus 0.4054 all over minus 0.5k. So if we divide this one by minus 0.5k, what are minus 0.5? So our we take k here. This is k. Sorry. So we are going to get our k is what? 0.8108. So our k is 0.8108. So this is our k. So we are getting our k. So what else again? We have to find what is the reading of the thermometer after 1 minute. What is the reading of the thermometer after 1 minute? We can add our k to this equation because this is the equation we get when you get our constant. So we can add our k to this. We now have t is equal to tm plus 60 exponential minus k 0.8108 t. So after what is the reading of thermometer after 1 minute? So our t is equal to what? 1 minute. 1 minute. What is the reading of thermometer? We have to find our temperature of the body. So we are not given t. So we have to input this to this equation. So you can say this one is equation 1, equation 2, equation 3. So our t, we are not given t. So our tm is temperature of the surrounding. We just have to put 10 because we are being given 10 degrees Celsius already. Plus 60 exponential minus 0.8108. Our t is what? 1. So if you times, what are we going to get? We are going to get t is equal to what? 10 plus 60 exponential minus 0.8108. So what are we going to do here? We have been given, so what is our exponential minus 0.808? So we have to press exponential of minus 0.8108. So what's our exponential minus 0? So we have what? 0.8108. We get 0.4445. So our t is what? 10 plus 60, 0.4445. This is this. So 60 times 10, 60 times this, what are we going to get? We are going to get 26.67. So our t is what? 10 plus 26.67. So if you add 26.67 to 10, what are we going to get? We get our temperature as what? T is what? 36.67 degrees Celsius. So what is the reading of the thermometer after 1 minute? The reading of the thermometer after 1 minute is what? 36.67 degrees Celsius. If we want to convert it to a whole number, we get what? 37 degrees Celsius. So how long will it take? How long will it take thermometer to read 56 seconds? So we just have to here you should be able to do this. How long will it take thermometer to read 15 degrees Celsius? It means our thermometer, we have been given thermometer. We just have to use this formula. This formula, because we have gotten our K already, we have gotten our Tm is 10. So we have been given this one as 50. So we have to find t. So we'll be able to do this one again. So in the next video, we'll now be going to population codes. So don't forget to subscribe so that you can see my latest video whenever I upload. Thanks for watching. Thanks you so much.